Welcome back. We're going to now turn off this voltage source, turn on the first current source, turn off the second current source, and build our equivalent circuit. You can see in this exam it actually has a spot where they definitely want us to draw the equivalent circuit once we turn off these other two sources and just leave current source I1 on. So here we go. Remember, when we turn off the voltage source, this becomes just a closed circuit. So I'm going to draw this a little bit faster this time. Again, I'm drawing it in a way that makes sense to me. You might wish to draw it slightly differently. Please try to follow along. You can always pause the video and figure out what's making sense. Notice this is I1 is actually 1 milliamp. But I'm just going to keep it as I1 and then just fill in at the very end. Here's the shorted voltage source. That's that part of the circuit. Right here at this node, this part of the circuit. This is going to be open, so I'm going to ignore this part. So I've just got this. And again, these three are going to end up in series just like before. And that's my equivalent circuit that I need to look at. That's the circuit. I'm going to make some simplifications. Again, we know this simplifies to 8 just like before. And as before, this whole piece right here simplifies to 1 resistor, 1 4K resistor. And let me redraw it once again real quickly. I'm going to combine these two, which are in series. And there we go. All right, so now let's see what we've got. I'm going to just call that VA, just in case I need to know it. So we can see that we've got a little voltage divider action going here. We've got just a drop here. Now we know this whole node right here is grounded. So at this point, this is a little bit more difficult circuit to analyze. And so let's do it. We know that this is a voltage divider, so we know that V5 will just equal VA times 6 over 6 plus 6, which is equal to VA over 2. So that's, once we know what VA is, we'll know what V5 is. And then to know what VA is, we know that as the current flows through here, it's got to drop. So we'll do it this way. I'm going to redraw the circuit once again to something a little bit more convenient. And if I was fresher in my experience, I would have drawn it this way right from the beginning. Okay, so I'm going to do some current analysis. I'll call this IA. I'll call this IB. And this is still I1. This is VA right here. So we know that VA is going to equal just the drop across this resistor. So IA times 4. These are kilo ohms. We also know on the other side that VA must equal the drop across this resistor with the current going in this direction, going down. The current going down is actually negative IB. So negative IB. And these resistors are in series, so it's 12K. And we also know that I1 must equal IA plus IB. And so we've got 3 equations and 1, 2, 3 unknowns. So we should be able to solve this. We can put IA is equal to VA over 4K. And over here, IB is equal to negative VA over 12K. We can plug that in here. So VA over 4K minus VA over 12K. That must equal, remember this is a known value of 1 milliamp. So it's 10 to the minus 3 amps. And so we've got VA 1 over 4 minus 1 over 12. Sorry about that. Again, just to recap, I created 2 currents, IA and IB. The voltage drop from here to here must equal to VA, so VA is equal to the current times that resistance. Voltage drop from here to here is also VA, so it's equal to the current flowing in this direction, which is negative IB, times the total resistance. These are in series, so that's 12K. We can solve, and we also know that I1 must equal IA, which flows up, minus IB, which flows down. Oh, whoops. Minus IB, which flows down. And so we solve for VA, use 3 equations, 3 unknowns. We solve for VA, which is IA, which is VA over 4K, and plug it in here. And we solve for IB, which is negative VA over 4K. And we get this equation. And I1 is equal to 1 milliamp. Factor out VA. This becomes a plus. 2 negatives. We can simplify this as 4 over 12 or 1 over 3. So we've got VA is equal to 3 times 10 to the minus 3. And assuming I did all my units correctly, that would be volts. So that means we can now solve for V5. So V5 is equal to VA over 2, which is equal to 3 times 10 to the minus 3 amps over 2, which is equal to 1.5 milliamps. Whoops, excuse me. Volts. 1.5 millivolts. So this is the contribution to the voltage across the resistor R5 from the current source I1. And I'll stop there, and then we'll move on to the next source.